Welcome to the Explainer. I'm absolutely thrilled to have you here today because we're going to uncover something truly fascinating. We're looking at how the fundamental principles of mechanical motion, literally the basic push and pull of simple machines, are actually the hidden blueprint behind our biology, modern technology, and yeah, even artificial intelligence. Think about it. Everything from the heavy physical machines grinding away in our factories, right down to the microscopic neural networks firing in our own bodies, it all operates on the exact same basic idea. It's really all about transmitting power, momentum, and information from one place to another as efficiently as possible. And I gotta tell you, once you start seeing the world this way, absolutely everything connects. Okay, let's take a quick look at our roadmap for today. We'll kick things off with the mechanics of motion, types of physical gears, and biological engines. Then we'll scale things way up to look at the gears of AI, complex tech ecosystems, and finally, the future of systems. Let's just dive right in. So Section 1, the mechanics of motion, the fundamentals of transmitting power. To really wrap our heads around these highly complex digital and biological systems, we first got to ground ourselves in some basic physics. It all starts right here. The whole essence of a mechanism boils down to the relationship between the driver gear, that's the one applying the input force, and the driven gear that receives it. By just tweaking the sizes of these gears, engineers can perfectly adjust the speed or torque ratio of a whole system. So you want more torque? You reduce the speed. Want more speed? Well, you're going to have to sacrifice a little bit of torque. It's this perfect, totally logical transfer of energy with basically zero slippage. Moving to Section 2, types of physical gears, meshing metal to solve physical problems. Because the physical world is messy and complex, engineers have spent literal centuries developing different configurations of these toothed wheels to transmit forces in some pretty ingenious ways. See, every physical problem needs a specialized solution. Spur gears, for instance, are simple and great for parallel shafts. But honestly, their straight teeth make them pretty noisy at high speeds. So engineers came up with helical gears. These have angled teeth for much smoother, quieter high-speed transmission. What if you need power to turn a corner? Well, bevel gears transmit force across intersecting 90-degree shafts. And if you want to bring a massive, heavy system to a slow, powerful crawl, a worm gear gives you extreme speed reductions. We've also got rack and pinion setups to turn rotational motion into straight linear motion, and of course, epicyclic or planetary gears, which are amazing at sharing incredibly heavy loads inside a really compact space. What's super interesting here is how specific mechanical needs completely dictate the gear's design. Take a look at the rack and pinion. It perfectly translates the circular turn of your car's steering wheel right into the linear left-to-right movement of the tires. Or look at those epicyclic gears. Their ability to handle massive torque in such a small footprint makes them the absolute standard for something as heavy-duty as a helicopter turbine engine. It's just brilliant. Okay, so we've clearly mastered the physical transfer of torque using metal. But that leads us to a pretty fascinating question. Does this exact same meshing concept apply to systems that aren't, made of steel and grease? Which brings us to Section 3, biological engines, the human body's interlocking systems. Moving away from metal for a second, we actually find that our own human bodies run on these deeply interlocking biological networks. They drive output just like a highly sophisticated gear train. And this illustrates perfectly how these biological gears actually function. Take the brain, for example. It works through dynamic network switching. You've got the default mode network, which is basically generating ideas, and the executive control network, which refines them. And these are toggled back and forth by the salience network. It acts exactly like a biological switchboard or transmission to produce inventive thinking. Meanwhile, down in the gut, the microbiome forms this continuous feedback loop with the brain. Specific bacteria levels actually mesh directly with our neurology to regulate sleep and impact disorders like insomnia. So yeah, you've literally got a biological gear train operating inside you right now. Let's jump to Section 4, the gears of AI, accelerating research and development. Because just as physical gears can multiply physical torque, the digital gears of artificial intelligence serve to exponentially amplify human intellectual output. Now, the absolutely crucial point here is this staggering metric on the screen, 500x. Think about this. An AI can process 5,000 research papers in roughly 5 hours. For a human, reading full-time, Monday through Friday, that exact same task would take 1.2 years. So AI is acting as this massive multiplier of our cognitive capacity, literally speeding up our ability to synthesize information by 500 times. That's just wild. And by utilizing advanced methods like cross-domain bridging, which is basically where AI identifies analogous concepts across entirely different scientific fields, it functions as a massive overdrive gear for research. For example, look at drug discovery. AI successfully identified 200 understudied proteins, and that directly yielded 12 new drug candidates for diseases that were previously considered completely intractable. The engine is just accelerating discovery at a pace we've never seen before. But, just as mechanical gears can create friction, AI algorithms act as highly complex mechanisms within our social ecosystems, too. We have to look at this objectively. Platform-independent experiments have shown that simply re-ranking social media feeds using AI can directly alter affective polarization and partisan animosity. It's a remarkably powerful transmission of information, and ultimately, the way those digital gears are arranged completely alters the social output we see. Moving into Section 5. Complex tech ecosystems, the planetary gears of modern business. Scaling up even further, we can see that modern digital corporations actually operate a lot like epicyclic or planetary gear trains. You have massive, interdependent systems orbiting a central hub to generate incredible market momentum. Google's ecosystem is a textbook demonstration of this concept. Think about it. You have Search, the Android OS, cloud workspaces, advanced DeepMind AI, advertising revenue, and all their smart home hardware. Now, none of these operate in isolation, right? They all mesh together, seamlessly feeding data and utility into one another to dominate global information discovery. Literally, one gear turns the next, creating this massive, self-sustaining engine. And this exact same mechanism applies right down to startup culture, too. Building a lasting AI company requires a really rigorous sequential design. It's not just about writing good code anymore. It's about creating a data flywheel. That's a structural loop where more users generate more data, which strictly leads to better products, which then trains better models, which in turn attracts even more users. It is a closed-loop mechanical system just applied directly to business economics. We also see this extreme level of system integration in military frameworks. Modern militaries are vast, interlocking networks. Land, air, sea, cyber, and space assets, they're no longer separate entities. They are synchronized by centralized AI integration for highly complex joint operations. It's really the ultimate expression of disparate systems being geared together to produce a single, unified output. Finally, we've reached Section 6, the future of systems, scaling up and zooming in. Because as our engineering capabilities advance simultaneously into both the macroscopic and microscopic realms, the mechanisms of the future are honestly starting to look almost indistinguishable from magic. Down at the microscopic level, we are pushing the absolute limits of physics to build atomic engines. We're achieving incredible world records, like fabricating a 1-nanometer gate transistor, or creating the fastest nanocar, which was actually driven by a team of researchers in Austria. We are literally, right now, building gears and transmissions at the scale of single atoms. No way, right? And then, zooming way out to the macroeconomic scale over just the next 4 years, AI systems are expected to shift gears incredibly fast. Starting from basic administrative automation in 2026, we'll see a rapid progression toward deeply integrated physical world applications. By 2028, we're anticipating autonomous emergency drones, and by 2030, the widespread deployment of driverless transit and even lifelike AI companions. The whole system is just speeding up. So let's take a step back for a second. From a simple mesh spur gear turning a wooden water wheel centuries ago, to the biological networks firing in our brains, all the way up to an artificial superintelligence analyzing the globe, the mechanics of motion, the transfer of power and ideas just continues to evolve. We've mastered the physical gears, and now we are rapidly mastering the digital and biological ones. Which leaves us with one final, pretty exciting question to ponder. As our tools become basically invisible and infinitely powerful, what kinds of incredible engines will humanity build next? Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.